9 here. And what is the value of 0.485? And what is the value of 9.8407? This one is actually, this one is the gravity, 9.81. This one is actually the specific gravity. And this one is actually the density of water. Remember, in test 1, you have to find the density of the fluid, right? By using the specific gravity. So it's the same thing here. Okay? And then the total pressure at the pump suction, you need to divide it into the pump, the suction part, and also the discharge part. So later on you find the difference. Okay? Absolute total pressure at pump discharge, this is the discharge part, just simply sum all the pressures. For the elevations, using the density of water, the specific gravity, and also the gravity. Sum them all, and the differential pressure is simply this pressure in the discharge side minus the total pressure in the suction side. And then how to find the head, like in tutorial, when you want to convert the pressure drop or whatever into head, you need to divide it with the density and also the gravity. Remember that one. When you want to change the pressure drop or whatever pressure, anything pressure, into head, you need to divide it with the density and also the gravity. For example, pressure drop due to friction. You want to change it into head. You need to take the pressure drop due to friction and then divide it with the density and also the gravity. Remember that one. Differential head is the conversion from the kilopascal into head, right? This is the density. Density of the fluid is simply the specific gravity times the density of the reference, which is water, times the gravity. So you get the head, and then at 10% safety factor, you have 9, and the total will be 98.4. Okay? Never mind. Calculation of the NPSH cell approach, just simply calculate add all the pressure and then convert into head. And that's it. Calculation of the actual horsepower. Not necessarily. The 10% share is stated. Here, with 10% safety factor. Okay, I'm afraid that your question will be like this. That's what I'm afraid, because the one that we discussed in tutorial is different, right? It's easier. Just simply calculate the pressure drop using the energy balance equation and convert it to power, which is very easy, using the movie chart, calculating Reynolds number, velocity, and so on. But this one is totally different. You don't need to calculate the Reynolds number, the friction, and everything. The pressure is already given to you. Okay, next one. Almost 4. Okay, so pressure vessel design. This is related to your group project. So whoever is in charge of doing the mechanical design, you will be lucky. Because, well, if you have done your part, the mechanical design, this part shouldn't be a problem. Because first thing that you need to do to calculate the thickness of the cylinder, right? And after that, you need to calculate the thickness of the head for all types of head. And whichever that has similar thickness to the cylinder, that will be the chosen head. Right. So, because I noticed that in Blackboard, you were given this discussion problem sheet. And when I look at this one, it's actually taken from 2014. See? This is your discussion problem, so I guess the question for design pressure will be something like this, which is very easy. Easy, right? Just need to use the equation here. And notice that in tutorial I showed to you, this one is, sorry, for the hemispherical head here. Remember in tutorial is given, the one that I showed to you, it's Ri instead of Di. But this one is actually Di, so this is the corrected one. This is given in Blackboard, and this is the one that we have in see, this is the one that I showed to you, and this is the one that given to you in Blackboard. Should be easy, right? Geometry and design data of vertical pressure vessels are specified in Figure 1. The dimensions shown are inside diameters, Di. Okay. Cost estimates are being prepared for this vessel. You are asked to estimate the required component thickness using the given design information and formula. Both heads are seamless. You need to highlight this one. With shell being double welded. Those keywords are important to get the joint efficiency factor. Right? Joint efficiency factor. How to get the joint efficiency factor? You need to refer to the table. Joint efficiency factor, see table 1. Table 1 is here. Right? Double welded and spot radiograph. Double welded and spot radiograph. So your joint efficiency factor would be 0.85. Easy. So how to answer this one, how to solve this? Just simply use the formula given here. This is for cylinder, this one is for cylinder shell, but remember you have two heads. One at the top, one at the bottom. So you need to do two calculations. One for the top, one for the bottom. They have different, the only difference here is the diameter. Yeah. What are the minimum required thicknesses for the two cylindrical sections? Do the calculation, substitute all the values. Operating pressure is already given to you. Remember the difference between operating pressure and also the design pressure. Design pressure you need to add 5 to 10%, right, to the operating pressure. Corrosion allowance is already specified here. Shell and head material. Design stress is also given here, but you need to convert the unit. And the joint efficiency factor is 0.85. So just simply substitute all the values here, you get the thickness of the cylinder shell for the top and also for the bottom part. And same thing with the hemispherical head and elliptical head. You need to do try and error. Find the one that has the same thickness to the cylinder part. For example, this one, the top part, although it's already specified hemispherical, but you still need to prove it, like you did or like you are doing for your group project. If you have any progress with your group project. This one should be easy. easy, right? Okay. So anything else? Under the pressure vessel design, theory and numerical. Numerical most likely related to this one, calculation of thickness of bar. The theory definition. You have two types of pressure vessels, right? One is the thin wall, the other one is thick wall. What is the difference between the two? And remember, well, in your group project, by right, first thing that you need to, okay. Now we are talking about the group project because it's also related. In a group project, when you prepare the group project, first thing that you need to state is which standard that you refer to. Either American standard, British standard, New Zealand standard, Australian standard. I will check on that one. If you don't have that one, okay. And then, after that, the things that you need to have, the 7 things that you need to have before you start the calculation. Design temperature, design pressure, what else? Design stress, joint efficiency factor, manufacture, what else? I don't remember the rest. And make sure, when you have done your calculation, you need to refer back to the standard and check if you are meeting the requirement, if you are meeting the minimum wall thickness, for example. If you are not meeting the minimum wall thickness, then you have to take the minimum value. Any questions on the pressure vessels? Any questions here? Should be easy. Normally it would be given like this, but don't trust the one that is given. Remember the correct one. Your experience from test 1. Reynolds number, it's given wrongly. Yeah. Make sure you know which equation correct, which equation is wrong. You need to correct it yourself. Well, if I notice it, I will make another one. But if I don't notice it, then you have to check it yourself. Okay, last one. Utilities. Very easy. Utilities, under utilities, what you need to focus more. Okay, let me go through the pressure vessels again. If anything that I missed. Things that you need to focus more on, one is pressure vessel definition, types classification. You have 2 types. One is the thin wall, the other one is thick wall. One is the ratio is less than 1 to 10. The other one is the ratio more than 1 to 10. Okay. Material construction, you know it. Stainless steel, carbon steel. Application example, just some example. How to design pressure vessels. What are the roles and chemical engineers. Probably you need to remember this. To provide the data to mechanical engineers. And what are the data that we need to supply to the mechanical engineers? Know the basic data, the data that we need to pass to mechanical engineers. Refer to the code and standard. You have many types of code and standard, right? And then the basic concept design, this is related to the shell of revolution. Shell of revolution. What is shell of revolution? We go back to the lecture notes. Calculation that you need to do, which is more calculation of the wall thickness and the calculation to determine which type of head that is the best one. And then joint efficiency factor, how to get them, depending on the degree of radiography and also the type of welding. This is specific for the butt welding type only. Okay? And then the equipment data sheet where you summarize, where you put everything, all the calculations that you have. And definition pressure vessels, the type classification, many types of vessels, basic data that you need to supply to the mechanical engineers, different code and standard, basic concept design, shell of revolution. You need to know the definition of what is the shell of revolution, and then you have different types of head. And the thing that you need to have before you do the calculation, okay? This is applicable to your group project as well. Join the calculation design pressure. Remember to add anywhere between 5 to 10% to the operating pressure. What happened? Temperature. And then design stress, how to get the design stress, this is very easy. Depends on your material of construction and also your temperature. Okay, and then classifications of different welding joints. Okay, we have 4 types: category A, category B, category C, and category D. Who knows, maybe this will come out in the test. We need to categorize the welding joint. To get the joint efficiency factor, depending on the degree of radiography and also the welding type. Okay, and illustration of the different part welding, either single welded or double welded, different type of welding points. Joint efficiency factor, how to get them. Construction, this is not that important. Corrosion allowance, remember the standard one is 2 mm. When you do the calculation, don't forget to add the corrosion allowance. You can choose any number if it's not specified, but if it is specified, then you have to use that one. Okay, and then the other equations which take into account the corrosion allowance, the design loads, major loads, this one related to your group project, loads that you need to consider, wind loads, dead weight loads, and so on. But the test will consider that one. Minimum practical wall thickness, remember, after you have done the calculation, you need to compare this one, depending on your diameter. Diameter, for example, if you use 1 meter diameter, the minimum thickness should be at least, the minimum wall thickness should be at least 5. So if you get less than that, you need to use the 5 instead of the one that we have calculated. And then next one is the calculation that you need to do. You have so many equations there. Either you memorize them in case it's not given. You have only a few equations, right? The wall thickness for the cylinder and also the thickness for the head. And in tutorial how to get the CT value and DE, and how to get the RC and CS. Okay, that is from textbook. Data sheet. Okay, now utilities. This is the idea that you need to, how to study the utilities. You need to know the types of utilities, the description of each utility, issues, before the issues, the type. This is especially important for cooling water. You have the open system, you have the, what is the other one? You have open system and you have the closed system. And then issues with each utility. For example, the cooling water, you have scale formation, how to prevent the scale formation, and so on. And my questions last year related to the, before that, I forgot to show you the questions related to pressure vessels that I had last year. In your own words, briefly explain how would you design a basic pressure vessel. the steps that you need to have to design the pressure vessels. You need to explain it yourself. Okay, you can read it. First one, gather all necessary information, basic data. And then second one, actually the second one is supposed to be the first one. First thing, you need to report, you need to refer to the content standard, because using the content standard, you will know what kind of information that you need to look for. Because the content standard, it will give you guidelines. It will give you guidelines. So it should be the first one before the gather all the necessary information. Okay? And then use the basic concept of pressure vessel design, which is the shell of revolution, and then calculate all the necessary measurement, specification, example, the wall thickness, the selection and type of the head with load, support, and etc. Summarize all the data in the specification data sheet. That is the general way to perform the design of the pressure vessels. Okay? And the calculation one, the calculation, I didn't show you the solution here, but it's same thing. Using the formula, calculate the thickness, and then choose the one which, the type of head that has the same thickness as the cylinder part. Okay? So the questions on the utilities, my question on the utilities, the UC sometimes doesn't really, but because it's already mentioned, right? You will have theory questions on the utilities, so it will be maybe something like this. Give 4 methods to prevent scale formation, or definition, what is scale formation? What is the cause of scale formation? 4 methods to prevent scale formation: increase the resistance purge, soften, make up water, use acid treatment to reduce CO3, use scale inhibitor. My students, previous batch last year, they get very low mark here because they think that this topic is not important. Many of them, they get less than 5. GRIP gives 3 common issues from steam distribution and propose how to deal with it, how to solve it. Hard expansion, heat loss, formation of condensate. Okay, done. Any questions? Any questions related to the things that you need to prepare for the test, and also maybe things related to your group project? Anyone? And beside attendance, where is the attendance list? Where is the attendance list? Okay, it's here. Anyone? Haven't signed? Okay, hopefully my revision is enough.